my pleasure to attend this webinar, and then we'll be going to talk about the wood properties and different applications. Let me just start the presentation. Yeah, so far our two colleagues, they have discussed a lot of properties which are related with the wood identification. So here just I would like to tell that when we talk about the wood, generally the names which comes to our mind are the conventional timbers like teak wood, rosewood, uh, sandalwood, what is called the honne, mati, they are the local names, Tercorpus marsopium, and then Adna cardifolia, Rhytia tinctoria, Soria robusta, and then Sisam, Delvergia, Sisu. These are the different timbers which are generally being used earlier for different applications. But nowadays, these timbers are less available in the market because of their overexploitation, and they are having very high cost. So it is very difficult for the common people to afford these timbers. And now a lot of plantation timbers and imported timbers are available in the Indian market. So the plantation timbers are the fast-grown timbers which are grown outside of the forest. That is called the TUF timbers, trees outside of the forest. They are available for different applications, and probably their wood quality or wood properties may not be as good as the conventional timbers which were grown in the forest and were long duration timbers. So it is very essential for the consumers to know the difference in the wood quality, and what for these timbers, plantation timbers can be used depends on the different properties they possess. Here is a list of the different timbers species which are available. They are around 4,000, and wood species are around 4,000, and out of that, having timber value is only 1,600. A number of species which are studied is around 500, and having commercial value is only 160. All wood species cannot be used for commercial applications, so there are only few species. And many of the plantation timbers, they are fast grown, short rotation, small girth timbers. They are all, and they also belongs to secondary timber species, as well as the hybrids and clones whose properties and wider applications are particularly not well known and need to be studied for different applications. So in India, we have only not many institutes which are involved in such kind of studies, like our Institute of Wood Science and Technology, Forest Research Institute, Dehradun, Kerala Forest Research Institute, and IPRITI, Bangalore. They have been working on testing the woods from different species, and based on their properties, they have been recommended for different applications. So here the slides is just to give a demand and supply scenario and the different sectors, important sectors in which wood is being used. So we can see the demand of the wood. India is a wood deficit country. A lot of wood and timber is being required for different sectors, but the supply is only 60 million cubic meter. This is estimated figure in the year 2020. And most of the timber is coming from the plantation forestry or social forestry, which is being grown outside of the natural forest. Whereas the demand for the timber, you can see it is 153 million cubic meter in the year 2020. So if you see the difference, there is a huge difference between demand and supply. And these are the different sectors like where wood is being used: construction, joinery, furniture, and packing cases. These are the different sectors. Pulp and paper and panel products. Of course, fuel wood is also wood is being used as a fuel wood for energy purposes. So to meet this ever increasing demand gap between demand and supply, what we are doing is that we are trying to use the wood which is grown outside of the forest, mainly from plantation forest, farm forestry, agro-based systems, and the motto here is the grow more and use more wood, and rest of the wood is being imported from different countries in form of logs, sawn timber, semi-finished and finished wood products. So a given wood can be used for what applications depends on the properties of the wood material. Here are main wood properties or quality parameters. These have been classified as anatomical properties, chemical properties of the wood, physical properties of the wood, and mechanical properties of the wood. Under anatomical properties, as our previous speakers they have elaborated that gross anatomy, vessel fiber, and ray morphologies comes under this category, and these anatomical properties are required for wood identification. Then we have the chemical properties of the wood, because wood is a kind of natural polymer which consists of cellulose, lignin, hemicellulose, and extractives. And the chemical properties are required for pulp and paper as well as for wood composite applications. Similarly, for physical properties, like wood is a hygroscopic material, so what is the moisture content in the wood, what is the density, shrinkage, color, texture, grains, these are the properties which comes under the physical properties category. And similarly, the mechanical properties of the wood being used for different applications like construction and building and flooring and beams and columns. So many applications of the wood where mechanical evolution of the wood is required, and strength, stiffness, compression, shear, tension wood, hardness. These are the properties which are categorized under the mechanical properties. So these are required for different in-use applications. What is the importance? I just mentioned that we have to generate the knowledge, scientific knowledge, for rational utilization of the wood. Wood is being a precious material. We have to use it rationally. So where we have to use the right species for right usage with the right price. We should not waste the wood for high quality wood should not be used for lower grade applications like packing cases. We should not go for very high quality woods. So depending upon the application, we have to choose the right timber species. And finally, we have to study the wood, and based on the properties, it has to be recommended for inclusion in the BIS, Bureau of Indian Standard list, for large scale applications and utilization by different agencies. So as far as anatomical properties are concerned, already my previous speakers have mentioned about that, so I will not go much into detail of these anatomical properties, because this is of course what previous speaker told. It anatomical properties are required for identification and certification of wood species and assessment for different applications. So, and it will also be used for checking the adulteration, substitution, and fraud happening in this field. So these are being studied in different sections like cross section, tangential, and radial sections, and based on the wood elements, the wood can be identified. Next is the physical properties. These are very important, particularly the moisture content of the wood, density, and shrinkage and swelling, which determines the dimensional stability of the wood. Apart from this, the color, percentage of hardwood, and grain structure, texture, figures, these are all also comes under the physical properties of the wood. So moisture content is very important. Wood being a hygroscopic material, it absorbs moisture or water vapors from the atmosphere, and we have to determine the MC value or the moisture content value in the wood by using a method under which is mentioned in the Indian Standard 1708 1986. Any dry wood which is kept outside generally contains a moisture of 12 plus minus 2%, and this is taken as the equilibrium moisture content. When the tree is felled, it is called the green wood, and the moisture of that in that condition may be as high as 100%. So that moisture need to be uh, removed in a controlled way so that the amount of moisture present in the wood should come around 10 to 15% when the wood is to be used for different applications like for furniture or for construction. So this process is called seasoning of the wood. So as per the Indian standard, when we want to determine the amount of moisture which is present in the wood, we have to take a small piece of wood and take the weight of that wood piece, keep in the oven at 103 degrees centigrade for 24 hours minimum, and then we have to take the weight again, and using this formula on the dry weight, one dry weight basis, we have to determine the amount of moisture which is present in the wood. When wood is dry and like 0% moisture content, there is no moisture or water present in the wood fiber. But from 0 to 30% range, the water is mainly present in the cell wall of the fiber. And when moisture of the wood is more than 30%, the water is also present in the cavity of the so the water which is present in the cell wall is called the bound water, and the water which is present in the cavity is called the free water. So when wood is dried, the free water is evaporated first, and then below 30%, it is the bound water which is removed. So study of moisture content is very important because when moisture is high, maybe as high as 20% or little more, then the fungus may attack the wood, and the quality of the wood may get deteriorated. So control of the moisture and drying of the wood is very important. The second important parameter, physical parameter, is the wood density. It is the amount of mass present in a unit volume. As we know, the density varies considerably between different species. You can find very light species in terms of density, and at the same time many species which have very high density, and the density depends on the wood structure as well as the moisture present in the wood. So there is a formula to compute the density, like a specific gravity at the test, weight by volume. This is a simple formula, and generally specific gravity is calculated on the dry weight basis. That is one dry weight divided by volume in the green condition or very high moisture condition. So this is called the basic density or standard specific gravity. Both parameters are being used in the trade. And the importance of the study of the density is that density is generally taken as an indicator of basic wood strength. So as a thumb rule, we can say from this graph also that higher the density, better the strength of the wood. So high density wood is generally behaves as they are very strong wood. And it also reflects the cost of material handling and transportation, because higher the density means we are also carrying the water along with the wood material. And in commercial field, wood density is also being used for classification of the timber. This is a scale which is called the wood density scale. You can see here the density varies from 0.1 to 1.3. So 0.1, there is a very light wood which is called the balsa wood. It is the lightest wood, and there is a heaviest wood which is called the lignum vitae. The density of the balsa wood is around 0.15, as well, whereas the lignum vitae, the heaviest wood, has a density of around 1 point, more than 1.2. So this is the range of density variation, and softwood and hardwood both comes under this density variation. You can see on the left side, these are the softwoods. Pine having the density of around 0.6, spruce having the density of little more than 0.3, whereas hardwood, teak wood is having a density of around 0.6, acacia 0.7 to 0.8. This is the density variation. Now, why the density variation happens? Because of the internal structure of the wood. The low density wood has different structures compared to high density wood. Teak is a medium density wood. So you can see the difference between the structure and correspondingly the variation in the density value also. Based on the density, the woods are also being classified in different groups. That is like very light group, and then light density group, moderately heavy, heavy, very heavy, and extremely heavy, depending upon the density of the wood at 12% moisture content. If wood is very having the density less than 300 kg per meter cube, then it is called the very light wood. Moderately heavy, having the density in the range of 451 to 600. Similarly heavy, 601 to 800, and extremely heavy is 950 and more. These are the density scales and density classification. Now next very important property is what is called the sinkage and swelling. Wood being a hygroscopic material, it absorbs the moisture, and when it absorbs the moisture, it starts swelling. And it is when opposite to this, when moisture is removed from the wood by drying process, wood starts sinking. So sinking is the reduction in the dimension due to removal of moisture from the wood. And when we don't remove the moisture in a controlled way, then because of the differential sinkage behavior of the wood, splitting, warping, opening of joints will come into the picture, and they will create the problem in our furniture and other items. So it is very important that wood should be seasoned properly, and once wood is seasoned, then only it should be used. Would basically have three principal directions. One is the longitudinal direction, another is the radial direction, third is the tangential direction. And sinkage is having this sinkage or swelling, they are different in different directions, like radial and tangential and volumetric. Volumetric is like to put together whole volume of the wood. So and the radial, tangential, and volumetric sinkages are different in amount. Here we can see the radial sinkage varies from 2% to 6%, whereas the tangential sinkage varies from 5% to 10%. Longitudinal sinkage is of course very small, like 0.1 to 0.3%. Longitudinal sinkage, longitudinal direction is along the fiber direction. And volumetric sinkage is the total of the previous three, radial, tangential, and longitudinal. So this varies from 8 to 18%. So there is a difference in that radial and tangential sinkage. Tangential sinkage is generally 1.5 to 2 times greater than the radial sinkage, and this is the property which is called the anisotropy. So wood being an anisotropic material, it reflects in case of sinkage and swelling behavior.